All right, the last page of the mixed notes. So, 15 years ago, Shayla deposited $4,000 in an account earning 5% interest. So, she makes a one-time deposit, earning 5% interest per year compounded every 6 months. She then adds $1,000 into the account at the end of each 6-month period over 15 years. How much money will be in the account at the end of 15 years? How much interest did she make on her investment? We actually did one very similar to this, which I forgot time on, which I probably wanted to take that problem out, but I'm going to leave it. We'll solve this one. All right, so this is one where there's two parts to it. Right, there's the regular payments of $1,000 at the end of each 6-month period to twice a year. And then there's the one-time deposit of $4,000. All right, so I'm going to plug in two money amounts. And then we want to figure out, well, how much will she accumulate at the end of 15 years, and then how much of that accumulation is interest. All right, so first thing we want to figure out is the future value. Right, how much money will be in the account, and then we'll figure out the interest. So N is our compounding period, which is 2, over our time, which was 15 years, so 30 compounding periods. Interest was 5. So this time we're going to fill in all 3 of these spots. So the present value was the initial deposit, and again, it's got to go in there as a negative, right? I'm taking $4,000 out of my pocket and depositing it into an account. I can't touch it for 15 years. Same thing with the $1,000. She's adding $1,000 every 6 months, so twice a year she's investing $1,000 into this account. Every time she invests it, she takes it out of her pocket. So you've got to remember that's $1,000, and you have to remember those two negatives there. They both have to be negative. Future value is what we're going to look for, and that'll come out positive. But remember, the present value and the payments have to be negative. It's very important. If you put one of those in there as a positive number, it's assuming a different counting technique, and so you can't do that. All right, compounding period, payment period is the same, and it's 2. All right, twice a year. 6 months, right? Twice a year. All right, so what's the accumulation? So the first part, how much money will be there at the end of 15 years? So the future value at the end of 15 years, we accumulated with all of our dollar amounts and our interest, $52,292.97. So we would assume this is some type of IRA, individual retirement plan. So in 15 years, so she was working for 15 years and she saved up this amount. She invested it in a stock or some type of investment account, and she accumulated $52,000. At the end of 15 years, she can now use that $52,000 however she wants. All right, so that's the first part. That's how much money she has in the account. The second part is interest. So this is the one where you have to do a little bit of thinking. How much interest did she earn? Well, in this case, the big amount is the future value. All right, so we take the future value and we subtract all her payments into the investment. And so we take the future value minus the original present value, the $4,000, minus all her $1,000 payments, right? And so we take the $52,292.97 that she has, subtract away the $4,000 she invested, and subtract away the 30 payments of $1,000. So 30 times, right, because over a 15-year period, twice a year, she invested $1,000. That's $30,000 just right there. So she personally put in $30,000 into the account, plus another $4,000. And so altogether, that's the amount she invested. The rest of it came from the interest that compounded over 15 years. Which in this case, since the time is a long amount of time, it's actually a significant amount of interest. She earned $18,292.97 in interest over the 15-year period. Because again, she didn't touch her money for 15 years. So that's extra. That's money that she got by investing. All right, next example. Gretchen started a new job. All right, she intends to deposit $300 at the end of each month into her pension, which earns 5.4% interest compounded monthly. She plans on making deposits for the next 40 years and then retire. During her retirement years, she will be paid a monthly pension based on a 25-year payout. How much will she receive monthly while retired? All right, so this is a pension example, which we did one like this in the 2.3, but this one's set up as a little different because there's different information that I know and different information I'm asked to find. Right, but there's still, you break it down into retirement and working years, right? Those are the two things. So we will have to fill out our TVM solver twice. We'll have her working years and her retirement plan, right? And you can set them up. We'll do working years, which were working, she's planning to work for 40 years. And then the retired years. Retired plan, and her plan is based on a 25-year payout, which means the pension will last for 25 years. If she lives beyond the 25 years, she'll have exhausted this particular retirement plan. Then she'll have to live off Social Security or whatever retirement she's got out there. All right, so those are the two things. So I've got to fill out my TVM solver twice for the working years and the retirement plan. All right, so I'm going to start with the working years and fill out what I know. So again, N for the working years is compounded periods, so 12 months, over 40 years, right? 40 years are her working years. And so 300 are the amount of payment she's going to make while she, 480 are the amount of payment she's going to make during her working years into the retirement. Interest is 5.4, PV, PMT, and FV. All right. There is no present value. She starts her job, and there's $0 in her pension. She makes her first paycheck at the end of the first month of her job, right? And at the end of that paycheck, she's going to deposit $300 into her pension. And so there's $0 in there initially. She's going to make a regular payment of $300 at the end of each month. So after the first month went by on her job, there's nothing in there, and then she makes her first payment. Making a payment into the pension, once you plug it into the pension, you can't touch that money until you retire. All right, so it's a negative because you're putting it in there and you can't touch it because you're investing it and somebody else is going to use your money while it's being invested. And then we're going to figure out the future value. How much will she accumulate in her pension at the end of her working years, which we actually need to know that in order to figure out her retirement plan. All right, so compounding period and payment period is the monthly, right? Compounded monthly, paid in monthly, so those are both 12s. And so we're going to figure out this future value. How much does she accumulate while she's working? Right, this would be what's in her pension. And so we fill that out. So for, again, plug it into the calculator, the TVM solver. Comes out to $508,614, and we'll round to the penny, 90 cents. All right, so she's got a little bit more than $500,000 in there. All right, that's her retirement accumulation. So at the end of 40 years, and that would be just hers. Now, typically an employer also puts them in there, and will probably match it, so it would probably be about the exact same amount of money from the employer, but we're just assuming right now she's basing it off of what she's putting in. All right, so at the end of 40 years, she'll have $500,000 in her pension. All right, well, now we're going to do out the retirement plan, right? That's what we want to figure out. How much will she receive when she... Basically, what can be her income from her pension once she's retired? That's what we want to figure out. All right, now we do have a different time period, so N is different. It's still compounded monthly, so it's still 12, but now it's 12 times 25. Her interest rate, though, is the same. That's still 5.4. Present value, payments, future value, and then again, these are still the same. That's still 12. All right, so you do have to change N. 12 times 25, that was the 300. All right, so 300 payments she's going to plan on when she retires. And then what happens here is this is the amount in her pension. And so that becomes the present value in her retirement. That's the amount of money sitting in the account, earning interest that she's going to withdraw from. And so that future value becomes the present value in her retired years. And so you basically are going to move that up, and when you do move it up, it becomes a negative because you can't pull out the $500,000. Right? You only pull out a little at a time. So right now it's a negative. The payments are the positive part, the little bit you can pull out. At the end, again, it's based on a 25-year payout, so at the end of 25 years, if she lives that long, $0 she'll exhaust her pension. She'll have $0 left in this particular pension. That's why usually you have more than one retirement plan. Alright, so we've got that in there. We are going to figure out how much can she live off of per month. And so we figure out her monthly payout. $3,093.04 and change. And so again, that's per month. That would be her income now, right? She retired, she's no longer working. Her pension is what's going to pay her when she's retired. And so she has to budget then. She can spend $3,000 a month for 25 years. All right, that's how much she'll have every month to live off of during her retired years, at least from this particular pension. All right, so that's their pension plan. So again, it's similar to what we did before, but it is a little different than the one we did before. All right, you might want to look at the one we did earlier was set up kind of backwards to this. All right, next example. We did do one like this one as well in this 2.3 notes. Kim wants to buy, because this is probably more related to what you guys are looking at right now, right? You're not looking for retirement yet. But you will probably buy a car eventually sometime. And so suppose that Kim wants to buy a car. She's figured that she can afford, based on, how much she gets paid and all of her other bills, she can afford payments of $190 per month. All right, she's talked to the bank, and they're willing to give her a 7-year loan at 4.8% interest compounded monthly. What's the maximum amount she can borrow to purchase a car? Again, how big of loan can she get to buy her car? And so we're figuring out the present value, right? How big of loan can she have? Right? And compounding period, so 12 times 7, right? It's for 7 years, which is a bit longer. Most loan for cars go 5 years. Right, so we have a 7-year loan for the car, which is 84 months, 84 payments. Interest is 4.8. Present value is what we're looking for, right? How much can she take out in her loan? We know she can make payments of $190. That's a positive amount because she's paying off her debt. Future value is 0 because at the end of 7 years you'll have paid off the loan, so nothing's left owed to the bank. Those are both the same, which are monthly, so that's 12. Right? How much can she spend? Basically, how big of a loan can she take out? Right, comes out to $13,532.64. And so, if she's not making any down payment at all, this is how big of a loan she can get. So her car can't go over $13,532.64. That's all she can afford based on her budget. All right, that's the loan amount. And didn't ask to figure out any interest, so that's it. Just the loan amount. All right, that finishes up the review, which again is just a sample of some of the questions, not all of the types. It's a sample. If you want to look at all the types, you have to go back over all of the notes and look at the mixed review and the extra practice sets and the practice quiz. This is, again, just a sample compilation of some of the different ones I wanted to hit again, mixed all together in a review. A quick note about some of the web-assigned problems and the book problems. Sometimes they give you I. This is an example of actually a problem from the book. Dave was charged $500 on his credit card. He was charged $1.75 per month. If you'll go and look, all of the problems that I give are always giving you an interest rate compounded over a certain time period. All right, so compounded again over a certain time period. This is actually giving you the monthly interest rate. This is actually telling you I, which is R divided by M. And so it already broke it down by and divided it by the per month. All right, so it's not giving you R, it's giving you the month case. All right, everything in this case is terms of month. And so if you wanted to figure out what your interest rate was, you actually have to work backwards from that I. All right, our interest rate would be, well, I've got to multiply by M to figure out what our interest rate. So it'd be M times I. Well, our interest rate would be monthly, so 12 times that 1.75%. And so the interest rate would actually be 21%. All right, again, I don't typically ask questions like that. I won't. There won't be anything like that on the quiz that I write or the final exam. But the book, if you're looking at some of the book problems, the book does do this occasionally. This is, like I said, this is one I pulled from the book. And so what the book is giving you, they've already found the I. All right, remember in all of our formulas, I is a part of the formula. And so the lowercase I, not the uppercase I. And so to figure out the interest rate, if you wanted to plug it into calculator, you have to work backwards from that I and figure out what the interest rate is. All right, so again, this is just a quick note about this. This is just for WebAssign. If the WebAssign gives you a problem like this, where they've already broken down the interest per month, is usually what they break it down as. They've given you I. All right, so just make sure you're aware of that from the book. Like I said, the quiz, I won't do that. I'll always give you R. All right, I'll always give you the compounding one. All right, so if you notice it, it's compounded twice. This is the interest rate per month compounded monthly. So they've already broken it down per month and compounded monthly. All right, so that's the difference in the problem. The per month part, the extra per month part. All right, so just be aware of that when you're working through the book and the WebAssign problems. All right, and that's my FYI on the end of that notes there. All right, so we'll finish it up there, and we're all done with chapter 2.